Hello all, welcome to this online recording sessions in data science. So in this session we are going to see some of the NLP techniques that can be useful in our data science. Okay, so NLP stands for natural language processing, right? So let us see some of the techniques that are mostly used in NLP. So NLP, when coming to NLP, it is mostly used when our data set is in a form of text format. Okay, in the most in text format, if it is there, we'll go with NLP technique. Yeah, if you look into this terminologies, tokenization. So what is tokenizations? So we have bunch of text, right? So we will have some text. So this text need to be tokenized first. So on the whole, if you dump 4 to 5 pages of text and trying to convert them into vectors, that is not correct, right? So first we need to tokenize them. Okay, so this is the text. Imagine if you want to just to convert all this into vectors, because machine understands only vectors, right? So if all the text is in vectors, we can directly go to into machine learning. Since our text is since it is not in vectors, we need to convert this text into vectors. Then we can go with NLP techniques. Okay, so for converting all the text into vectors, we need this NLP concepts. Okay, so this tokenization involves two types. Okay, tokenization involves two types. One is sentence tokenization. The other one is word tokenization. Okay, tokenization is of two types. One is sentence tokenization, the other one is word tokenizations. So out of all the bunch of the text, we'll break the text into sentences. Okay, how do you break how system understands whether it is sentence or not? We have a lot of text, right? But system should understand where the sentence is ending. So how can we tell the sentence is ending? If we have full stop. Okay, if you have full stop, then we can tell there is a sentence. Okay, and the sentence is getting ended. If you have another full stop, we can tell another sentence is ending. So in that way, if you in our code, if you give full stop as a command and ask it to separate it wherever it is there, we can break them into sentences. Then next, word. How system can understand whether it is a word? Okay, we can understand, but how to make system to understand whether it is a word or not, right? So if you consider this text, say suppose, consider this text. Okay, how many words are in there? If I ask, what you will tell? 3 words, right? So I am telling it is a word because there is a gap. So if I recognize space, white space, can I call it as word? Yes, right? So if there is a white space, here is also one white space. So if there is a white space, then I can tell it is a word. Okay, I hope you understood. Sentence are recognized by seeing the full stop, whereas words are recognized by seeing white spaces in the text. Okay, next, stemming and lemmatization. What is stemming and lemmatization? What is stemming and lemmatization? So we will be breaking the entire text. So we will take a text and we will be breaking them into sentence. So from the sentence, again we will break the sentence into words in tokenization concept. But what is stemming and lemmatization? Say suppose we have words like this: running, runner, runs. So I want to, is there any meaningful sentence? So after, is there any meaningful sentence? Altogether means same, right? Running means same, runner means same, runs means same, right? Altogether means running is the root word for all these three words. So out of all the words that we have got, what we need to do? We need to see meaningful words, whether they are meaningful or not. Okay, that we will see in the stemming. Okay, so in these three words, I can consider run as a stemming word. Okay, run is common in these three words, and I will consider this as a stemming. Okay, so then what is lemmatization? Lemmatization is also same as stemming, but what is the difference? Lemmatization is breaking the words, recognizing the words into meaningful dictionary words. So I may consider the root word for all these three words as run. Okay, if I have play, player, playing. So what is the root word for all these three words? Play, because play is common in all these three words. In the similar way, in this case also, if I have eat, eating, eated, okay, these three words. So in these three words, what is the root word? If I ask, what is the stem word? Eat, right? Okay, so we have considered this as root words. So this root from the original words. Okay, so these root words, whether they are meaningful or not, we don't know. Okay, so stemming technique involves just considering the root word. It don't bother whether it is a meaningful dictionary word or not. If we don't have any meaning to that root word, then what is the use? We don't have any use to that root word, right? So we should have a specified dictionary word, root word, that we can find it in lemmatization technique. Okay, stemming and lemmatization techniques are nothing but breaking the words, considering the words into a meaningful or root words. Okay, so when we can use stemming technique and when we can use lemmatization technique, that all depends, right? Okay, that all depends. When we have large data set, we can use stemming. When we have small data sets, we can use lemmatization, because stemming will be faster. Stemming, lemmatization. Okay, so what is the difference? This can be used for long texts. This can be used for short text. This is faster. Okay, this is time taking or slower. Time taking or slower. Okay, this is may not be correct. May not be correct. So our prediction or our root words may not be correct. But in lemmatization, the root words are dictionary word. Root words are dictionary words. That means it has meaningful. So even though it is time taking, it is better to go with lemmatization. Okay, it depends situation. Okay, so if it is time consuming, we can go with stemming. So not in all the cases we may not get a wrong, right? For some words we may get wrong root words in stemming techniques. That's why we can go with lemmatization. So it all depends upon the user who is using, depending upon the text, whether to go with stemming technique or lemmatization technique to extract the meaningful root word from the words. Okay. Okay. Next, removing stop words. What are stop words? Stop words are nothing but which have no meaning. Say suppose, let us take some sentence. I am eating in the dining hall. Say suppose, let us take this sentence. So if you consider these words, I am means it may represent me. Eating means I am doing some particular task. In what is the meaning? If we convert these words also into vectors finally, so what meaningful insights we can draw giving it to a machine learning model? So on the whole, we will convert all these words into vectors finally. Then we'll apply machine learning or whatever the technique we want, right? So if I convert these unmeaningful words into vectors, what is the use? Do they have any meaning? In means, do they have any meaning? And is, do they have any meaning? No, they don't have any meaning. They are just used to combine sentences. And is used to combine two sentences. Is used to point out something. Okay. So like this, there are some stop words. Okay. The stop words are nothing but which have no meaning to the words. Okay. So we can remove it, right? If there is no meaning to these words, we can remove it. So we will be removing it before converting into our text into vectors. Okay. So that is the use of removing stop words. What is stop word and removing stop words? Next thing. Okay. So our text cleaning will happen. Okay. So we will have a bunch of text. So we will be cleaning it. First pre-processing and cleaning should take place, right? So in that cleaning process, we will remove exclamatory marks, inverted commas, special symbols. Okay. All these symbols, text means generally it consists of all this, right? So all these are special symbols. So we can remove all these things in text cleaning. Okay. So we have some special libraries in NLP where we can do text cleaning. Okay. So after removing all these special symbols and everything, then we can apply these techniques. Okay. So finally what we will get after text cleaning? We'll be left with meaningful words. Okay. So to that meaningful words, what we need to do? We need to apply some techniques. Techniques like bag of words, TF, IDF, word to VEC. So these are some of the one-hot encoding, label encoding. So these are some techniques to convert words or text, I can say, into vectors. Okay. So after all these steps, you come with this step. Okay. These two are some of the techniques that are used to convert the words into vectors. Okay. Yeah, I hope you understood this terminologies. And there are some terminologies we can call sentence as corpus also. Okay. So like that, some terminologies also there in NLP. Okay. So let us go to next slide. Yeah. So we will see some words converting into vectors theoretical. So how they will be converted? So suppose I have 3 sentences. So in these 3 sentences, what I will do? I will use a bag of word technique and I will try to convert this into vector. So for converting this into vector, what I need to do in bag of word technique? So first you need to see in this 3 text how many are there. So how many different words are there? Good is there, faculty is there. Okay, good is repeating again. So mentor is another word. Mentor, faculty already there, good is also there. So there are, in these 3 sentences, there are 3 different words, right? So what I need to do? I need to make 3 cross 3 table. So I have made 3 cross 3 table and I have specified different words from out of all the sentences that I have taken. So I have mentioned different words that have been chosen. Okay. So good, faculty, mentor. Now you see in text 1, you tell whether good is present in first sentence. Yes, right? So put 1. Okay. Faculty is present. Yes, put 1. Mentor is present in first sentence. No, right? 0. 0, 0. Similarly, in text 2, good is present, that's why 1. Mentor is present, that's why 1. Remaining all zeros. Similarly, in third sentence, what do you have? We have good, faculty, mentor, faculty, good. So all the 3 words are there. So that's why I have taken all 1, 1, 1. Okay. So this is the simple bag of word technique that can be used. Okay. It's simple, right? Just putting 1 and everything, right? So what if the case is very, very big text? Okay. What is the case is very, very big? In that case, bag of words falls a drawback. Okay. We need to go with other techniques. Okay. Bag of words can be used for only small text. Okay. If the text is small, then we can go with bag of words simply like this. Okay. We can convert like this. If you ask me, it is somewhat similar to one-hot encoding and label encoding. Okay. So next technique, what it is there as per our discussion, TF-IDF, right? So next we will going to see what is TF-IDF. Yeah, TF-IDF stands for term frequency and inverse document frequency. Term frequency, inverse document frequency matrix. So we will be having formulas to this. So we will be calculating term frequency separately, inverse document frequency separately. So in term frequency, this is the formula that we'll be using, and inverse document frequency, this is the formula that we will be using. So we will take some sentences and apply this technique, and let us see. Okay, see, same text what I have taken for bag of words, I am also taking it for TF-IDF. So first step what I need to do in TF-IDF, calculate TF separately, then IDF separately, then multiply both TF and IDF. Okay, so in this TF, so we have a formula, number of repetitions of any word by number of words in a sentences. Okay, so now you tell me number of words in the sentences. So number of repetition of any word, how many are there? Good is repeating how many times in this sentence? 1. Okay, right. So how many are there? Number of words in the sentence. How many words are there in these sentences? 2, right? So 1 by 2. Okay. So similarly, I will write 1 by 2 as here. Okay. So total there are two words. Okay, for this. So everything by 2. Okay. So similarly, so good faculty. Okay. Good faculty 1 by 2 and 1 by 2. So total there are 2 words, good faculty, good 2 words, right? And for good it is 1 by 2. Okay, this is number of repetition of words. If it is good is repeating 2 times, it will be 2 by 2. If my sentence is like this, what I will get? How many are there? Good is repeating how many times? 2 times. How many words are there? 2, right? 2 by 2. It will be 1. Okay. Then I will need to put that value here. Okay. So yeah, let us come back to this. Yeah. Next, similarly faculty also. Next, in text 2, what is there? Total 2 are there. So by 2. So by 2 for all. So how many times good is repeating? 1 time. So 1 by 2. How many times faculty is repeating? 0, right? So 0 by 2. So how many times mentor is repeating? 1 time. 1 by 2. Next, in text 3. So how many times mentor is repeating? 1. So total there are 3 words in this sentence. So everything by 3. Everything by 3. Okay. So total how many number of words are repeating? Mentor is repeating how many times? 1 time. So 1 by 3. Faculty is repeating how many times in this part? Whole sentence 1 time, right? So 1 by 3. So similarly, mentor is repeating 1 time. faculty is repeating one time, good is repeating one time. So this will be the calculation for TF. Okay. Next we need to calculate IDF. Next we need to calculate IDF. So IDF also will have separate formula, log of it is related to sentences. Okay, log of number of sentences by number of sentences containing that word. Okay, so total how many number of sentences that we are having? 3, right? So by 3. So log of number of sentences. So how many sentences? 3, right? By number of sentences containing that word. Good is containing in how many out of all these 3? 2, right? 3 or no. Here 3, right? So 3 by 3. Log 3 by 3. So answer will be 0. Okay. Similarly, so now you tell me for this word. So how many number of sentences are there? 3. Okay. So number of sentences containing this word. So how many out of all these 3? How many sentences containing faculty? 1. No, 2, right? So 1, 2. So 3 by 2. Okay. So log 3 by 2 is 0.17. So similarly mentor. So mentor you tell how many sentences. So total there are 3 sentences. In these 3 sentences, how many in how many sentences the mentor is repeating? Once, twice. So 3 by 2. It will be 0.17. Okay. So if you observe, we are getting most of the values within the range of 0 to 1. Okay. This is the advantage in TF-IDF. But if you see in a bag of words, the value ranges from 0 to 100, 200 also, it will be there. See, in bag of words, it is like this, right? So if it is 100, 200 also, it will be ranging and it will be extending. But if you use TF-IDF, it will be ranging within 0 to 1. That is very, very advantage. If it is ranging to 0 to 1, what is the use? Okay. What is the use? It is machine understands zeros and ones only. And there is no need of scaling. Okay. So if the values are too high, what we'll do? We'll do scaling. So no need of scaling also. When we apply TF-IDF. In least cases, we can use scaling. Okay. So that is also one of the advantages using TF-IDF technique. I hope you understood this technique also. So next, we will multiply this. Okay. So what TF value we got and what IDF we got, we can see here. So our TF value is 1 by 2 for text 1 and 0 for, and this is TF and this is IDF if you see. So TF is 1 by 2 and our IDF is 0 for good. So that's why we are considering 1 by 2 into 0. Similarly for text 2, faculty also you can calculate 1 by 2. 1 by 2 for faculty 0.17. 1 by 2 into 0.17 and you can get this value here. Okay. So 1 by 2 into 0, it is 0. Okay. So in this way we can multiply TF and IDF and get the values like this. See, finally we are getting within the range of 0 to 1. So that is the advantages. That is the advantage if you apply TF-IDF. It will be ranging it within 0 to 1. Okay. And it is better than bag of word technique. Okay. Although it is time consuming and it is involving calculation, it is better than bag of word. Okay. So now let us see some practical implementation of this technique. Okay. So I'll try to cover some concept in this. Okay. So next, So let me use this pen. So let us see the practical application of this concept that we have seen. Okay, so first thing, so what are the libraries that we need for implementing NLP techniques? We can use NLTK, we can use glove. Okay, these are some of the libraries that we can use to apply NLP techniques. So out of these two, NLTK is very popular and it is very easy. Okay, so I will be import NLTK. Then what I will do, I will take some sentences. Okay, so I have taken one variable, and in that variable I will be using some text. Okay, so I'll be using some text. Okay, so let me add this to this already existing one. Okay, so I'm taking some text randomly from Google. Okay, I think it is visible. Okay, so I have taken, so first I have import NLTK library, then I have taken one sentence. So now what is the next step I need to do? Let us check whether this text is working or not. So that's why I'll print it in the next step. Okay, so after printing it, then I will download Punket library. Okay, this Punket is used to, it is helpful in sentence tokenization and word tokenization. Okay, so now I'm printing also. So see, this is the text that I have added to my already existing text. So it got printed. That means my text is better to use. So the very first step is you take the text, you take the library. In that library, you take one variable, and into that variable you take some text, and to that, and then next you download Punket library. Okay, so that Punket library will help us in sentence tokenization and word tokenization. Okay, first what tokenization can be used? First a sentence, right? So in the sentence, in the meaningful sentence, we can go with word tokenization. Okay, first sentence tokenization. Okay, sentence is a variable, and what is the function that I am using here? What is the function that I am using here? So NLTK is the library sent underscore tokenize. Then you give the variable where our text is stored. Okay, so this is the code that we need for sentence tokenization. Similarly, for word tokenization, NLTK dot, we can put it as word. I have taken sentence as variable for this command. NLTK dot word underscore tokenize. You give the speech, or you can give the sentence word also. You can give this also, because, or else you can do it in the directed text. Our directed text is speech. Our sentence text is the word, the variable that is having sentences. Okay, okay, now let me run it. Yeah, so how many sentences I got? Let me check it. Name sentences is not defined. Sentences. Okay, why it is coming like this? Let me give another variable and check it. Sentence 1 is equal to null ticket, or what is the error I am getting? So I am getting error. So why I am getting error? NLTK dot sent underscore tokenize speech. So I'm getting error because of Punket library, I think. So let me check it. Why this is happening? I think I have not used Punket library correctly. Okay. So I think there is some error in it. Okay. Um, can I use this? No, right? Okay. Downloading Punket. So you can search it. I think it is the issue with Punket library. Okay. Punket tab. And so what? I think it is in closing only, but I'm checking it whether it will be working or not. No, it's not working. Then I need to consider this only. Then run it. Yeah, I'm getting error in Punket library. So, but we will, or the Punket library couldn't recognize some of the special symbols. I hope. Okay. Okay. Maybe I'll try to cover this in the next session. Okay. So after breaking into sentence, the next one, what will I give? Speech dot split. What is speech here? What is speech here? Speech dot split, right? Maybe it is capital and it is small here. No, it is variable. Why I can't use, right? Okay, I'll check it. So next, what we'll do? So we will print length of the sentences. We'll get sentences. How many sentences are there? So after sentence tokenization, we will get the word tokenization. So all the sentences will be broken down into words. See. So if it is broken into words, how we will get? We can see it here. Okay, natural language processing and so on. The words are getting separated, okay, from the sentences. So how many words are there? There are 94 words. Okay. So next thing what I will do, remove the stop words and apply stemming. So in stemming there are different algorithms. So Porter stemmer, I have Porter stemmer and snowball stemmer and so on like that. Okay. I have Porter stemmer and snowball stemmer. So these two are the algorithms that can be used for stemming. Okay. So here I have used Porter stemmer. So then if I run it, so see, so all those are, will be converted into root words. Then what is my next step after applying stemming technique? You need to convert into root words. Sorry, we need to remove stop words. So what are the stop words that are available in English? You can check it here. So you can remove this English and you can give UK English or United English. So there are different languages. So that language you can give it here. So system analytical library, our analytical library, we can understand all these things. Okay. So this English I have given. So what are the stop words? These all are the stop words which have no meaning. So I will try to remove all these words that are there in my words. Okay. That is called stop word technique. Okay. So I need to remove them because they don't have any meaning. So I'll apply all the sentences in the for loop. For one sentences if I apply, and the same logic if I put it in the for loop, it will be applicable for all the sentences. Okay. So for all the sentences, I am applying stemming and removing stop words. Okay. See. So what is the stem word of natural? It is nature. N-A-T-U-R. So if you see, consider this N-A-T-U-R. Do that have any meaning? No, right? It doesn't have any meaning. So that is the drawback of the stemming techniques, as we have discussed. But in case of lemmatization, it will see whether it is a dictionary word or not. Okay. So that is what we can see in the next lemmatization technique. Okay. So in lemmatization, you can check it, you'll get it, the correct one. Okay. Correct root word. N-A-T-U-R, natural, we make it natural only. Okay. Okay. Then what we will do? After removing that, we will be applying bag of word technique or TF-IDF technique. So if I apply bag of word technique for the above sentences, what I will get? I will get like this, all the vectors. So you can see what are the vectors that I am getting for the particular text. So for natural is converted into 0. Okay. Language is converted into 1. So like that you can see the vectors are represented here. Okay. Okay. Then if you take the shape, what will get 3 cross 40 means 3 rows, 40 columns. Okay. Then you can apply TF-IDF technique also in the similar way. Okay. Import TF-IDF vectorization from sklearn. Sklearn has this thing to convert into vector. I think bag of word also is present in sklearn. So sklearn consists of this vector conversion technique like bag of word and TF-IDF. Okay. So we will converting into array. So in the array form only we can visualize. So that's why we are converting. So TF-IDF we have converted, and we can see the vectors in TF-IDF technique also. I hope you understood this. So thank you all. In the next session, I'll try to show, I'll take some text and apply some NLP concepts and come again. Okay.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.